Chapter 10, Sample Problem 7. Each of the 10 point masses in each case identical. The solid line in each figure represents an axis about which the masses are going to be rotated. The point masses are fixed together so that they all maintain the arrangements shown while being rotated. And we'll assume that the not bolded lines are masses because they don't say anything. Rank these arrangements on how hard it would be to start the system rotating. So how hard it will be is the same as saying by I. So we want to find out I for each. So if we assume that each ball is of mass 1 and each segment is length 1, then here we have 3 times 0 squared plus 3 times 1 squared plus 3 times 2 squared plus 1 times 3 squared, which is down here 0 plus 3 plus 12 plus 9, which is a total of 24 for A. For B, we have, this is 2 masses at a distance of 2, and 3 masses at a distance of 1, and 3 masses at a distance of 0, and 2 masses at a distance of 1, which is 8 plus 3 plus 0 plus 2. That seems to be 13. For C, we have 3 times 0 squared plus 2 times 1 squared plus 2 times 2 squared plus 3 times 3 squared, which is 0 plus 2 plus 8 plus 27, or 37. And then finally, we have 2 times 1 squared and 3 times 0 squared and 2 times 1 squared and 3 times 2 squared, which is 2 plus 0 plus 2 plus 12, which is 16. So we end up with clearly C is the most, A is the next, D is next, and B is barely but is the least.